Welcome back to the Deep Dive. Today, we've got a pretty unique mission, actually. We're focusing on designing a strategic, sort of hyper-efficient recovery plan for a very specific listener. You. You're the programmer who, hit level 11 competence in one of those rigorous C curriculums. You definitely know your algorithms, you get system calls, you've built some pretty big projects, but you've taken a break. And those skills, they're probably feeling, let's say, a little dusty.
That's exactly right. And this isn't about going back to square one. Not at all. Our analysis shows you've got a high baseline already. You've conquered the foundations. So our goal isn't remedial work. It's about rapid skill reconstruction. We need to pick projects that are, challenging enough to force that immediate recall and get you those satisfying aha moments again, all while giving you visible, tangible proof that you're back on track.
Right. Tangible proof is key. We're curating this path specifically because, well, you're likely working independently now, right? You don't have the mandatory deadlines or, the peer validation pushing you. So the project itself, it has to be its own reward.
Exactly. Motivation is critical here. Hashtag strategic assessment, avoiding the basics.
Okay, so let's unpack that baseline a bit more. We know you've already jumped through the initial hoops. You've definitely conquered Lift, the C-string library. You mastered memory allocation with malloc. You tackled complex data, sorting with push-swap. And you even finished massive team projects like the Core War virtual machine and that pathfinding challenge lemon.
Which means, and this is crucial, we absolutely cannot waste your time on peer revision. Re-implementing, say, a simple linked list from scratch, that offers basically zero value at this stage. We've got to avoid that kind of intellectual boredom, the stuff that makes people quit, Instead, we need pressure points, projects that force you to re-engage with complex memory and operating system concepts simultaneously.
Okay, that makes sense. We've kind of boiled down the target knowledge, the stuff you really need to hit hard on your return, into 3 essential focus areas. What's priority 1?
Priority 1 is C foundations. Yeah, but C foundations with teeth. That means remastering memory management, pointers, malloc, all that stuff, but not in isolation. It has to be within a really complex system context. Think like multi-process environments where pointers are flying across shared memory spaces, that kind of thing.
Got it. So moving from just simple data structures to thinking about architectural memory concerns.
Okay.
What's the second critical area then?
System logic. This means plunging right back into operating system fundamentals. Things like processes, managing files efficiently with descriptors, and critically, concurrency, how to deal with multiple things happening at once. You just can't really call yourself a level 11 programmer without knowing how the Linux kernel or any OS kernel really fundamentally operates.
Right. And the third area, the one we both agreed is super critical for someone learning on their own.
Motivation. Yeah. The project absolutely has to have a clear, visible payoff. When you finish coding it, you must have something tangible you can point to, like a graphic rendering on the screen, a working network connection you built, or, your own functional command line shell. That visible outcome, that's the psychological anchor. That's what ensures you actually push through and complete the project.
Okay. So based on those 3 criteria, tough C, deep systems, and visible results, what types of projects really hit that sweet spot?
Well, we looked at the curriculum options and isolated 4 main categories that seem to work best. First, low-level System C projects that just demand rigor. Second, let's call them fun graphical projects for those visual wins. Third, the more demanding network OS challenges that build really professional skills. And finally, the massive projects, the ones that combine heavy technical lifting with really clear, demonstrable results you can show off. Hashtag phase 1, rapid skill reconstruction, system warm-up.
All right, phase 1. This is about shaking off that rust and doing it fast. We're targeting short, high-impact projects here, stuff that's typically, 50 to 70 hours? This is all about immediate reinforcement of low-level C and those core Linux system calls. So where should you, our rusty programmer, start to feel the productive pain and the reward quickest?
Okay, the absolute top recommendation for immediate systems fundamentals has got to be PyPEX. It's typically around a 50-hour sprint project time. And it's excellent because it forces you, immediately to understand the Linux process environment, specifically pipes, forks, and execve.
Now, hold on. For you, our listener, can you quickly break those down again? I know they're core DNA, but the terms can sound like, jargon if you haven't touched them in months.
Good point, yeah. So fork, that's how a running program basically clones itself. You get 2 separate processes from one. A pipe, That's the simple kind of one-way communication channel between those two processes you just created. Think of it like plumbing and execve. That's the really crucial moment where the new process, the clone, stops running the original program's code and instead starts running a completely new command, like fic or grep. So pipex forces you to orchestrate those three things: fork, pipe, execve in sequence. It mimics exactly how a shell command like sgrep actually works under the hood. It's a truly fundamental system mechanic.
Okay, that makes the why much clearer now. That sounds like a really powerful 50 hours of focused training. What's next for a quick system scale up?
Next up, I'd suggest Mini Talk. Also around 50 hours. This one's short, very instructive, and it focuses entirely on inter-process communication, or IPC. But it uses signals, specifically SIGASR1 and SIGASR2. You're basically building a simple client-server app where the client has to send a message, character by character, over to the server using only these tiny binary signals.
Huh. Okay, so if Pipex is about processes talking through, like plumbing the pipes, then Minitalk is more like passing notes using signal flags or light switches.
Exactly. That's a great analogy. It forces you to really manipulate individual bits in C, convert characters to bits, send them reliably, and handle them on the other side using the OS's built-in signal mechanism. It's a fantastic test of bit manipulation skills and thinking about reliable data transfer between completely separate programs.
Okay, interesting. Now, quick sanity check on the absolute foundation. What about Get Next Line, GNL, longer, 70 hours, and kind of notorious for memory management rigor?
Yeah, GNL. Look, we only recommend doing GNL again if your first attempt was, let's say, shaky, or maybe you skipped it or didn't fully finish it rigorously. If you totally nailed Get Next Line the first time around, honestly, skip now. But if you suspect your grasp of file descriptors, using read correctly, or dynamic memory allocation really needs that hardcore enforcement, the kind that frankly, makes you want to tear your hair out sometimes, then yeah, it's a good fail-safe before moving on. Otherwise, though, the pure systems focus you get from Pipex and Minitalk is probably a better use of your limited recovery time.
Makes sense. Prioritize the system interactions first. Hashtag TaxTech Phase 2, the core challenge. Concurrency and consolidation. All right, so once Phase 1 has hopefully restored your confidence in those basic system calls and managing memory, we need to transition. It's time for the hardcore challenges. These projects really require those solid C foundations from Phase 1, and they introduce concepts that are absolutely essential for modern programming, like dealing with multiple things happening at once, concurrency.
Right. And this is where we demand a huge conceptual leap, but also a huge payoff. The first crucial project here is Philosophers. 70 hours. This one is, well, universally described as a major high-stakes challenge. It focuses entirely on concurrency and synchronization. It's the classic dining philosopher's problem brought to life in code.
Wait a sec, 70 hours? That seems almost suspiciously short for a project tackling such a massive conceptual hurdle. This is where deadlocks live, right? Race conditions. Why prioritize this specifically over, say, jumping straight into a massive consolidation project like Minishell?
That's a really critical question. We prioritize it because the payoff to time ratio is just enormous. In those 70 hours, you're absolutely forced to use mutex's mutual exclusion locks and to truly understand threads. A mutex is basically like a key. You need that key to access a shared resource, like a fork in the philosopher problem. If you have 5 philosophers all trying to grab forks at the same time, you, the programmer, have to engineer a system using mutexes or other synchronization tools that prevents them all from getting stuck waiting for each other at the deadlock.
Deadlock.
Yeah.
The programmer's ultimate traffic jam. Everyone's waiting for a resource that someone else has locked, and absolutely nothing can move forward.
Precisely. And the really tricky part, debugging concurrency issues is notoriously painful because the errors often aren't deterministic. They might only show up under very specific timing conditions, these race conditions. So conquering philosophers means you fundamentally stop seeing your code as just a simple sequence of instructions. You start viewing it as multiple parallel streams of execution that need careful coordination. That mental shift, it's priceless. And it's absolutely crucial groundwork before you even think about tackling something as complex as building your own shell.
Okay, that makes a lot of sense. It's like a specialized, high-intensity crucible specifically designed to forge that core concurrency skill. So once we've survived the Philosopher's Feast, we need the ultimate consolidation project, the one that really ties every single system concept together. And that brings us inevitably to Minishell.
Yes, yeah.
Manisha. Around 210 hours estimated. This is the definitive consolidation project for this stage. Building even a simple Linux shell replica. It demands everything. You need parsing for the command line, stringing together complex commands with pipes and redirections, utilizing pretty much every system call you've learned. Pipes, forks, signals, handling environment variables, job control. It's all in there.
Whew. 210 hours, though. That is a huge commitment, especially for someone who's trying to rapidly recover their skills.
Yes.
Isn't that potentially too long for this reconstruction phase? Could it lead to burnout?
It is long, no doubt about it. But think of it as the final piece of glue holding everything together. If you can successfully build Minishell, you've basically proven mastery over, I'd say, 80% of the entire typical Level 11 curriculum's core concepts. It consolidates that foundational C rigor, the system logic, process management, signal handling. Everything comes together. Honestly, it is probably the single most formative project you can put in a portfolio at this level, and it fundamentally changes your relationship with the operating system. You understand it differently afterwards. So if you want concrete proof that you're truly back, Minishell is the answer. #tag phase 3 diversification and exploration.
Perfect. Okay, so with the C foundations feeling rock solid again from phase 1 and that critical concurrency and system knowledge locked in from phase 2, now we can talk about diversifying. Maybe, you want to focus on skills that are super relevant in the modern infrastructure world, or maybe you just desperately need a visual break from the terminal. We've kind of mapped out 3 distinct paths here.
Right. Let's start with Path A DevOps and infrastructure. These skills are, frankly, extremely sought after right now, and they often involve a bit less hardcore C coding and more system management and configuration. You could, for instance, tackle Born to be Root. It's shorter, about 40 hours. It focuses on system administration, user privileges, security hardening, setting up a secure Linux server from scratch. It's a quick, very high relevance project.
And for someone really interested in how modern applications are deployed, containerization is absolutely key these days.
Absolutely, and for that, there's Inception. Now, this one's bigger, 210 hours, similar to Minishell, but this project is all about Docker and containerization. You'll build a multi-service architecture using containers. While it is time-consuming, it's a great way to transition your C systems knowledge into highly marketable infrastructure skills. Alternatively, if you prefer getting your hands dirty with network protocols right from the metal up, you could look at building your own server. There's WebServe, around 175 hours for building a basic HTTP server, or Vesturk, also 175 hours, for building an internet relay chat server. Both require a really deep understanding of network sockets and protocol handling.
Okay, then there's Path B. This one's for you if you're just desperate to see some colors and movement after potentially weeks stuck in a black and white terminal. Visual gratification and math.
Yeah, the classics here are the graphic projects. You've got CubThird, around 280 hours, or Mini-RT, also 280 hours. CubThird is basically building a simplified Wolfenstein 3D-style engine. It forces you to implement raycasting.
Recasting, okay, refresh my memory. That's where you're calculating where, like, virtual rays of light shot from the camera hit objects in a 2D map to render a 3D perspective, right?
Exactly. It's this beautiful fusion of C programming, fundamental 3D vector mathematics, nothing too scary usually, and graphics logic. And the best part, you get immediate, colorful, visible feedback right on your screen. It's incredibly motivating. Now, if 280 hours sounds like way too much commitment for a fun project, there's also FDF, Fools Defer. It's shorter, about 60 hours. It's a more moderate graphical challenge, focusing on reading elevation data from a file and displaying it as a 3D wireframe relief map. Still gives you that nice visual win, but quicker.
All right. And finally, for the folks who just love a good brain teaser, the intellectually stimulating puzzle solvers, Path C, algorithmic puzzles, and data. Less direct system interaction, maybe, more pure thought.
Exactly. This path is really for the lovers of deep algorithms and data structures. A great example is NPuzzle, around 98 hours. This is a really rigorous algorithmic challenge. You're typically solving that classic sliding tile puzzle, like the 15 puzzle. It forces you to implement powerful search algorithms, often something like a search, to find the optimal solution.
A search. Right, that's the smart pathfinding algorithm. The one that balances the cost of the path you've already taken with, like, an educated guess, a heuristic about the cost of the path remaining to the goal.
Correct. It's a fantastic way to revisit complex data structures like priority queues and really get your head around heuristic optimization. Very satisfying when it works. Or if you want something that leans a bit more towards modern applications, you could try FT linear regression, about 70 hours. This project applies mathematical concepts to implement basic linear regression from scratch in C. It provides a surprisingly solid introduction to fundamental machine learning concepts.
And crucially, we're talking about managing motivation over potentially a multi-month recovery period. You absolutely need some quick wins sprinkled in there.
Oh, absolutely essential. You can't just grind on 200-hour projects constantly. Definitely alternate those big challenges with some of the shorter modules available. Look at things like the cybersecurity modules. They're often only about 7 hours each. Things like FTOT, one-time passwords, or Reverse Me, basic reverse engineering. Or maybe the Python modules, also usually 7 hours each. These offer quick, thematic variety. They give you a mental palate cleanser, build confidence with fast completions, and crucially, they help stop you from hitting the wall on one of those massive 210-hour epics. Hashtag add outro. Okay, so just to summarize, the most effective path we see for your rapid skill recovery and, importantly, confidence building. Start with those short, sharp system projects, probably Pipex or maybe Minitalk, just to clear out the cobwebs fast. Then move immediately into that crucial concurrency challenge with philosophers. You need to achieve that thread mastery early. And finally, consolidate all your system knowledge, parsing skills, everything with the major project mini shell. That locks it all in.
Yeah, that sounds like a really clear, strategically sound progression. It minimizes the boring revision and just maximizes the high-impact learning. Okay, so our final piece of advice to you, the returning learner, is all about strategic commitment. Fix a personal plan. Pick one primary consolidation project. Maybe it is Minishell, maybe something else appeals more, and try pairing it with one secondary fun or visual project, like Cub Third or FDF, to keep things interesting. And please, document your progress relentlessly. Write down what you achieve each day or week. Competence, yeah, it's regained by doing the work, but confidence, that's regained by seeing the hard evidence of what you've actually accomplished.
Definitely. We've basically engineered a roadmap here designed to get you coding advanced C concepts again, feeling confident, likely under 200 hours of really focused work. The question now really is for you to think about. Once the rust is fully gone, once you've conquered these essential milestones, what is the final, largest beast on this list that you will choose to conquer to truly cement your expertise? Will it be the massive 294-hour first-person shooter game Doom Nukem? Or maybe the incredibly deep 630-hour system dive into building a complex file system with KFS7, that ultimate challenge? And well, that's what truly awaits.